Um, Hello, guys.
Hello.
Yeah.
Yeah, I suspect you guys are the only ones who checked your email, right?
Oh, I texted my group about the emails. They know about it as well. They're just taking their time coming.
Okay. All right.
Yeah, there was I heard news about it. Like a classmate told me, and then I looked at the email.
You heard news about it.
Yeah.
What was it on Twitter or Facebook?
probably Twitter.
Oh, maybe on CNN or something.
The messenger bird just comes in and be like, "You got a new email, by the way."
All right. Let's wait and see.
Oh, Professor, I have a question.
hmm
So last class you said you wanted us to look at Starlink. Is it the SpaceX Starlink, or am I looking? Did I look at the wrong one?
I don't know. You tell me. Tell me how many Starlinks are there out there. Is there a new burger chain called Starlink?
What I looked at, it was interesting. I'm not sure if I looked at the right one, but like I can only hope.
Yeah, that's probably the only one. That's relevant to us anyway.
Yeah.
I seen something that said 1,000 cross-link satellites were up as of February.
Yeah, they're deploying more and more of it in bunches.
And
they just launched some today as well. It's like a couple hundred.
right, and usually when they launch satellites, the rocket gets wasted, but with SpaceX they can land the rocket, so it's a lot cheaper.
It blew up.
Yeah, but it blew up last time.
Yeah.
I think that's like the one problem with like trying to like save your spacecraft is like there is a chance for something like that to happen instead of just like dumping all the parts afterwards.
So I suspect that some people are not checking their emails because this is almost, we have 1 minute more. So, Will, you saw the email, right? Shenhui?
Yeah, I did.
So where's every other person here?
No clue.
I have no idea.
No clue, right? Well, people are coming, so I guess maybe they went to the other room and like, something is wrong here. What's going on? Omar, you saw the email, right?
Yeah, of course.
When 2 minutes ago?
Kind of, yeah.
Oh, 2 minutes ago, right?
No, it was a yesterday actually.
Oh.
I was busy yesterday, that's why I confused the days. I'm sorry.
Oh, so on the days that you're busy, you don't check your emails?
No, I'm checking. I'm trying to checking actually. I'm trying to do.
All right. So let's see who's here. Announce yourself, please.
Omar here.
Vincent is here.
Azim is here.
But he's here.
Will.
Zinan Paro.
Bobby.
Wait.
Josh is here.
Okay, so let's get it started. Yeah, we changed the ID just to keep things more organized and scheduled and recorded and all that kind of stuff. So it's a bit hard to juggle because I've got so many classes and I have to use different IDs, but we'll see how it goes. Let's see if it works and all that kind of stuff. Okay, so Omar, where are we exactly? What
In the last
what slide are we on?
broadband and baseband.
Bones?
Yeah, broadband and baseband.
Oh, I thought you said bones, like human bones.
No, I'm sorry about that.
Like, are we in like a science class or something? All right, so let's move on from broadband, and let's go to Ethernet. Ethernet. So, so Omar, where is how do you check your Ethernet again? Tell me. If I don't check my Ethernet speed, where do I go?
We are going to like checking. We can check online too on the browser.
What?
We can try to check our internet speed in online too. I mean,
I want to check my
system.
Ethernet speed.
in the system,
Ethernet.
you're going to control panel.
Why did you say go to the internet?
No. I just probably like suppose that you're meaning that speed. That's why.
Okay. Yeah, Ethernet.
The network and internet. You can click on the flag. And Ethernet connections. Yes.
So right here is your Ethernet connection here. It tells you your speed. And then you go into the interface here, and you look at the properties, and you can see, you have your MAC address there. You have all the configurations of the MAC address. You have your IPv4, your IP address, which is all connected to your Ethernet. And you can see the properties and stuff like that, right? So this whole business of Ethernet, with the cables connecting your computer to your router and all that stuff, it's a technology that was developed by a professional organization many years ago. So we're going to look at some technical facts right now, but Ethernet is a combination, like we see here. It's a combination of computers, switches, different kinds of cables that they all make that Ethernet technology that connects all the local area networks around the world. All right, so let's look at some technical details here. Now, there's a professional organization known as the IEEE. The IEEE, let's see, IEEE, IEEE. We call it the IEEE. That's how you say that, IEEE. So the IEEE is Institute of Electrical and Electronics Engineers. The IEEE, just like a lot of standards organizations that come up with standards and guidelines for different industries and different products, the IEEE is a group of professionals that produce standards and guidelines for networking, right? And one of those networking standards is the 802.3 standard, right, by the IEEE. I mean, you got to know the IEEE because you're going to see questions about the IEEE in your assignment. All right, so the Ethernet, like we said here, is made up of switches, computers, all kinds of cables, and this switches and the cables have to be made to a certain kind of specification so they can deliver a certain kind of, service or transmission rates, transmission speed, some kind of quality of service. They have to be designed in a certain way, right? The specifications of those products must be according to what has been laid down if you want to achieve some kind of results, right? Just like a whole lot of products have specifications. I mean, if you buy water bottles or you buy a car, inside that car you have a steering wheel, you have tires, outside you have a trunk, you have the hood, you have the engine. Everything is the specifications for the size of the door. I mean, if you, in your house, for example, you have doors. Those doors have certain specifications. So when you go and get a door, at Home Depot or something, you know what specification. The windows have a specification, right? There are different companies that build different components of products. Everyone has to know what is the specification that I'm building. What's the specification here? So let's go on a little bit here. Now, if you go to, so the best way for us to do this, because there are a lot of numbers and stuff, quite a lot. Well, let's do this first. Let's read something. Omar, let me go back to you here. Let's read something on page 136. It's going to help us, get a sense of what we're talking about here.
Page number which, Professor?
136. So let's look at where we talk about Ethernet standards.
Just wait 1 second. Yes. Internet standards, yeah.
So read that paragraph there.
Ethernet can operate at different speeds over different types of media, and each of the variations associated with a EAA standard.
IEEE.
Yeah,
IEEE.
IEEE. I'm sorry.
Okay.
The following section discuss many of these standards, some of them which are obsolete or had limited use.
Okay, so some of these standards are no longer in use, and some others are in use. All right, let's go to Kelly. Or let's go to Michael Tajali. Any of you guys, both of you, any of you. Let's read standards terminology. You see that? Standards terminology.
All right. Ethernet standards are generally expressed in one of two ways. One way is using the IEEE document number defining the standard. For example, IEEE 802.3 is the parent document specification for 10 megabytes per second Ethernet using the coaxial cable, which was ratified in 1983. All other variations and speeds of Ethernet are sub-documents of the original 802.3 specification.
Okay. Pratik, can you go on there with the other half?
The second way of expressing an Ethernet standard is use the X base Y terminology. Most IEEE 802.3 documents describe the transmission speed, types of transmission, and length or type of cabling, and are designed with terms such as 100 base T dot IN, 100 base T, for example. The 100 designates the speed of transmission, 100 megabytes per second. The base indicates a baseband signaling method, and the T specifies twisted pairs cabling. All the base T Internet standards use a physical star topology. The following.
Okay. All right. So now, what you read now might not even make sense to you. Like, what does all this stuff mean, right? There's so many numbers and so many, should I say, little, very detailed descriptions there. It may not really make sense to you. In actual fact, people who really care about this specifications are people who produce materials, who manufacture, equipment, networking equipment, right? But it's good for us to have an idea, some kind of an idea of what they're talking about, right? So we can relate to the whole, this topic here. So I think the best way to continue is if you flip over to this table on page 141. Page 141. So page 141, it gives us a table 3.3, right? It kind of summarizes all the different specifications and definitions and standards in this table, Ethernet standards and specifications. All right. Do you guys see that? You see that table, Zenon?
Yes. Yeah, I see the table.
All right. So how many columns do you see? The column headings.
7.
All right. So what do you have there?
Ethernet standard, IEEE document number, transmission speed, cable type, minimum cable grade, maximum distance, and design notes.
Okay. So the minimum cable grade, right? I think the last class we started talking about different categories. Well, we didn't really go into detail, but we're going to go into more detail in chapter 4. So just for one quick second, flip over to page 179. 179. We're going to cover it in chapter 4, where you guys start building your cables and stuff. But page 179, so you see a list there of different categories of cables from category 1 all the way to 8. Right? Zenon, you see that? So these different categories of cables, they have kind of like saying they have different jobs to do, right? All the different categories do different things. Now, category 1 to 4 are basically no longer in use, right? Old technology. The current technology in the United States is 5, 5E, 6, and 6A. 5 and 6, right? 5 and 6. 7 and I think even 8, yeah, are not used in the United States. They're used in Europe, in Asia, other parts of the world, but they're not used here because the technology, the truth is, the technology is at a different level. It's at a much higher level, right? The performance and the characteristics of category 7 and category 7.8, category 7A standards are, it says on page 181, the performance characteristics are well above the ones that we're talking about. So the ones that we have right currently in use is 5, 5E, 6, and 6A in the United States. So let's go back to that table and let's see, just a few things there that might make some sense. So I just showed you now my Ethernet information here. So you can see that my Ethernet information here, I have a speed of 1 gigabit per second. Now, the way you say that, when you talk about speed, it's always the first letter is capitalized, uppercase. So uppercase G, lowercase b. That is gigabits, not gigabytes. Gigabits per second. Data travels bits per second. Bits per second. So what you see there, that speed is gigabits per second, not gigabytes, or it might be megabits per second. All right. So data is uppercase, like GB, gigabyte, but speed is gigabit by bit. All right. So just to get that out of the way. All right. So if you look at the first one there, Ethernet standard 10 base T, excuse me. The document is IEEE document 802.33i, and the speed is 10 megabits per second. The cable type is UTP. Winston, what does UTP stand for again?
Unshielded twisted pair.
Unshielded twisted pair. Now, Winston, tell me, what is the distance, maximum distance of the cable, the length of the cable for category 3, 10 base T? What's it say there?
A meter?
What?
Category 3. I don't know, 1 meter? 100 meters?
Are you looking at the same table here?
Yeah, is it 100 meters?
Okay. So 100 meters is the maximum distance, right? For the cable length from one point to the next point. Now, look at what it says in the design notes. If you're going to have hubs, right? If you're going to have hubs between two computers, that is basically in the 100 meter distance, says the maximum number of hubs you can have is 4. So in terms of design, people who design networks and stuff like that, they have to abide by these rules. But if you look back at, where is it now? Well, we haven't actually reached there, right? So the weird thing is, there's a lot of discussion in this chapter about the category of cables. But the actual topic of cable category is in chapter 4. So kind of, I guess the design of the book, there's an issue there because we don't know much about categories. That's in chapter 4. But I'm just going to give you some background. I already pointed you to a couple of things. So the point is, category 3, category 3 and 4 are no longer used. So we don't need to, waste our time with. But I guess it's good for you to know that, like you saw on page 179 in chapter 4, you have about 8 categories of cables. All right. Now, the categories that we are probably more concerned about is anything in 5 and 6. All right. Anything in 5 and 6. And then when you look at the transmission speed, right? The transmission speed, let's see. So let me ask you guys, based on my transmission speed here, 1 gigabit per second. Will, let me go to you. When you look at all transmission speeds here, 10 megabits per second, 100 megabits per second, 100 megabits per second, 1000 megabits, 2.5, 5 gigabits per second. Look at all that and all that from top to bottom there.
Okay.
What is the most likely? Do you think that I have here? I know there's a lot of numbers, and some of this stuff might not make sense, but just look at that first page. Is there any of them that you think, okay, well, this looks like your speed here?
Either 1000 base T or 1000 base LX.
Yeah, you're right. I think you're right. So 1000 base T, that's the fourth from the top.
Yes.
Because when you convert 1000 megabits per second, you get 1 gigabit, right? So that's 1 gigabit. Unshielded twisted pair, which is what I have behind my computer there. Category 5, 5E, or 6. And you only need maximum 1 hub. Now, when it says hub there, right, it doesn't actually mean a literal hub. It's just the same word for a switch, right? So, because you might think, why are we using hubs? So it's like the term, right? That term has almost kind of stuck to represent, hubs and switches. So you just say hubs. It's like if I said, Will, if I want to tell you, go and do a search on the internet, I just say go and Google it, right? So it's a generic term for, switches and hubs. You understand? So don't think hubs there mean the actual hub. It's just a generic term for those kind of devices. All right? So, yeah, because I know that can be a little bit confusing. Like, I thought we were talking about switches. Why hubs? All right. So, yeah, because sometimes they use it interchangeably. Anyway. So, yeah, 100 base T, 1000 megabits per second, category 5. All right. Now, you can have speeds that are greater than that. If you have speeds greater than that, 2.5 or 5 gigabit 5G base T, they have speeds of, 5 gigabits per second. So let's see what else here. So let's look at that 100 base T. Let's look at it a little bit more, Will. Let's look at a bit more, should I say, description of the 100 base T, and that is on page 138.
1 second.
Yeah.
Okay. You just want me to say
Yeah, so let's just read that. It's a little bit of, a lot of technical stuff, but, let's just read it to get a sense of what it's talking about.
Okay. 1000 base T Ethernet released is the IEEE 802.3 AB standard, supports 1000 megabits per second Ethernet, usually called gigabit Ethernet, over category 5E or higher UTP cable. The 1 gigabit per second data rate results from sending and receiving data simultaneously in full duplex mode at 250 megabits per second in both directions over each of the 4 wire pairs in category 5E cable.
Okay, let me see if we can explain that. So you see the picture on my screen now, right?
Yeah.
So it says that the way you get your 1 gigabit is the design of this unshielded twisted pair has 4 pairs. Each pair is able to transmit 250 megabits per second back and forth, each pair. So 250 times 4, you get 1 gigabit per second. That is the design of this category 5, category 5E cable. So they all have their different specifications, right? I mean, way back with category 3 cables, right? Category 3 cables, what you have on page 137. Category 3 cables could only run what? Could only run about 10 megabits per second, which is, it's pretty low, pretty small. All right. Now, if you're excited about 5G, Will, you've heard about 5G, right? Who hasn't?
I have.
Okay. Everyone thought coronavirus started with 5G or something. Anyway, Now you see the next part there, 2.5G base T and 5G base T.
Yeah.
I think that's what it's referring to. But let's read it a little bit.
You want me to start reading that one?
Yeah, sure.
Okay. In September 2016, the IEEE ratified the 802.3 BV specification that defines 2.5 and 5 gigabit Ethernet running over Cat5e, Cat6 cabling. This specification was largely in response to increasing Wi-Fi speeds, with 802.111.11 AC Wave 2 access points coming to market that support speeds beyond 1 gigabit per second. Faster
Okay. Now, the next thing you're going to read there is a big deal. So go ahead and read it.
Faster wired Ethernet speeds are needed as uplink ports from these new 802.11 AC access points to prevent the wired connection from being the bottleneck on wireless LANs.
All right. Well, that's fine. That's just enough just for us to know. You guys can always look at more of that. But wireless works, off of wired networks, right? So it's telling us here, that there are potential problems with 5G wireless if some things are not, properly taken care of here. So people who build these things have to know the specifications and be able to work with them. For example, you can see back in that table that your cables can only be so long, right? Your cables can only be so long. So as the technology gets, increases, or we use different specifications, then maybe you can have, longer distances, right? So all those things there, if you look at it, there are a lot of factors why we can or cannot have certain things that we want to do. So there are a lot of numbers here again. It's a lot to digest in one go. But every once in a while, the IEEE it comes out with these recommendations and these standards that guide exactly what we do, right? So when you go and if you're a manufacturer of cables, for example, you got to know, how do I, they have actual documents, right? Actual documents that tell you how to build the cable. The twisted pairs, the colors, they all mean something, right? They all mean something, and they need to be done in a certain way to do the job they're supposed to do. All right? So you guys can take some more time and just look through all the different standards there. Or like I said, there's some standards that are not used in the United States, right up to what we focus here, what we use here is the 5 and 6 cable types, or should I say cable grades, right? Okay. Now, I didn't talk about this in the other class, but if you look at that page 140 at the very bottom of the page, Summer, can you look at that? That's kind of like, they're still working on this stuff. But if you look at that section there, it talks about 40 gigabit and 100 gigabit Ethernet, right? Right now we're talking about 1 gigabit internet, right? 1 or 10 gigabit internet. It's probably the most you get anywhere. Well, right there, there are plans in the works to go to 40 and 100 gigabits, right? Now, the kind of cable, the cable you use for that is what? Summer, what does it say there?
The cable. It would be fiber optic cabling.
Exactly. So, what you call it? Verizon calls it Fios. Maybe Comcast calls it Xfinity, whatever it is. But it's going to get to a point where the standard cabling is going to be fiber optic. And fiber optic, when we look at it, this picture here, when we look at it later and spend more time looking at fiber optic is designed to have no issues whatsoever compared to copper, unshielded twisted pair, right? Fiber optic is basically flawless. It can go further, it can go, the distances that fiber optic can go is incredible compared to copper. The security it provides, the amount of data it can carry, right? So what it's saying to us there is when it gets to that point where technology is able to take care of that matter, fiber optic cabling is the primary medium for supporting speeds that are, in the hundreds of gigabits per second. So, again, people whose job it is to build cables and to set up the internet and stuff like that, and the speeds that we work on is always based on, a lot of specifications that have been laid down. All right. Now, I just said something, and I'm wondering if anyone has a question about the categories that are used in the United States compared to other parts of the world where higher cable categories are used. So I'm curious, does anyone have any question about that? I mean, you don't have any questions in your mind when you hear stuff like that? Can you guys hear what I'm saying?
Yep.
Yes.
So you don't have a question in your mind when you hear that the United States is not able to adopt that you have higher performance in other places. It's like, yeah, doesn't matter. Who cares? It doesn't. There's no question in your mind about that, Vincent.
I kind of question why a bit. I just don't understand what each the categories mean enough to like fully understand why the U.S. doesn't do it yet. Like I'm reading it right now, and like I'm kind of getting confused. Like I don't get what's the difference between like what's a 5 and a 5E, and like I don't see a category 7 on the other the other page. So like
I said, right? For some reason, the book put the information about the categories in the different on the next chapter instead of right in this chapter. So we're talking about stuff that we haven't read about. So, but if you go to, just to get a preview, if you go to page 179, right?
Right.
179 has all the categories. Page 179, category 1 all the way to category 8. Right?
Right.
And of course, we probably have to spend more time looking at the different details, but I can say that category 1 to 4 is basically old standard because, okay, here's a quick run through. Category 1 was when we used phone cables, right? It was very low grade. So it's been scrapped, basically. Category 2 was only moving at 4 megabits per second, right? 4 megabits per second. That's impossible. Category 3 was moving at 10 megabits per second, right? Very, very low performance. So the higher the grade, right, the higher the speed that you can carry, so to speak, right? Vincent.
Right.
Category 4 was able to carry 16 megabits per second, which again is pretty low. Now, when you get to category 5, right, you start talking about 100 megabits per second, right? Which is, and also supports the, should I say, full duplex, right? Back, simultaneous sending and receiving.
Right.
And they can be used, with gigabit speeds. So it says right there in category 5, category 5E is the minimum recommendation because of the additional tests required for it. So category 5 is no longer available. So we've moved beyond category 5. So category 5E is the enhanced version, right? So category 5E, category 6, and category 6A, right, are basically the most common, right? Now, if you go to category 7, category 8, or rather go to page 181, right? Page 181, it says there that 2 additional categories are not in the standards yet, right? You can see that, right, Vincent?
Yes.
But it says, however, Europe has accepted those categories, the higher categories, 7 and 7A, right? The performance characteristics are well above. Do you see that?
Well above, yeah.
The performance, I mean, even if you don't understand, all these numbers, just understand that it's about performance, right? The higher the number, the better the performance. So let's just keep it simple. The higher the number, the better the performance.
Wait, so if Europe has already accepted the categories, then why doesn't the US accept it then?
Well, that's the question I was thinking you guys are going to ask me, but nobody was asking any question. I was kind of surprised because the other class, they were all over it. Like, what is going on here? What's happening? Why not? So what do you guys think? Even if you don't understand all these categories and numbers, just the fact that, the higher the number, the higher the performance. The US has 5 and 6, and that's the most we have, but other places have the higher numbers. So what do you guys think? Why do you think that's happening?
Is it a money issue?
Is it a money issue, right?
Could be. I don't know.
AB, what do you think?
Can you hear me?
Sure.
Can you rephrase the question, please?
What do you mean the question? We're just having a conversation, so I'm not sure what question it was. What question? What conversation are you hearing? What conversation were you hearing?
I'm not too sure.
You're not. Everything we're talking about, you're not hearing it. Is there something wrong with? I don't know. What do you mean you're not sure? What are we talking about right now?
Phrase the last thing that you were saying.
Okay, what's the last thing you heard?
Talking about the Europe and the cables, different types of.
Okay, so what did we say about that?
I'm not sure. That's why.
Well, what did you hear, rather? What did you hear?
Phrase.
No, I just want to know what exactly you heard, and then whatever has to be clarified will be clarified. So what did you hear?
Just the last thing was just talking about the cables. Someone asked why we haven't been using why Europe is using certain cables, and then you mentioned about how it's just we haven't done it yet.
So the question is, why are other countries around the world using higher cables and not in the US? That's exactly what you heard. That's it. So what's your response to that?
I'm not too sure on why it would be different. Yeah, I'm not too sure.
Well, it's not like there's no hidden answer. It's just something I want to talk about. It's not like I don't have the answer myself, but you know, the question has to come to you like, why? You know, um,
Uh,
yep, go ahead.
no, I'm just trying to think of like if like businesses or anything is just like different there. The only other thing I could think of is like just the layout of the land may be different, so they may have to use special cables. Um, yeah, that's what I would assume.
Yeah, I mean, you're not wrong. Obviously, there's going to be that as a factor, right? I think you just have to think about, how things develop, really, right? Um, you know, in terms of cost, obviously, there's money involved, right? In terms of the expense, how expensive it might be to deliver this kind of product, right? And the speed that we're talking about here. The consumers, I mean, can they afford to pay for it, right? The companies that make it, do they have the investment to do it, right? Do we have the right topologies, right? There's got to be a lot of stuff that you have to consider. It's like when you talk about cars, right? It looks like the gold standard car, AB, right, should be electric cars, right?
Yeah.
They're like supposed to be cleaner and more environmental friendly and stuff like that. But when you think about the cost of electric vehicles, right? When you think about charging stations, you got to create charging stations, right? The price has to be low enough for you and I, right? Just like you can get any other car right now.
Yeah.
So why don't we all have electric vehicles right now? I mean, we all like to have them probably. Everyone wants to have a Tesla maybe, but so there's a lot of factors I think in developing anything, no matter how good it is, things have to be planned.
Yeah.
And when you talk about high speed, I mean, I don't know. Things have to be planned. I think that's just the truth, right? Things have to be planned. I mean, I'm not saying that this is an issue here, but what is the population of the United States? About what? What's the population? It's what? Anybody knows the population of the United States?
Is it like 100 millions or so, maybe more? I'm not too sure.
According to Google, it's 328.2 million.
All right, so 300 million, right? Okay, so let's take a place like Japan, right? Japan has, for example, high-speed trains. You guys have heard about the high-speed trains that move at some crazy speeds?
Yeah.
Right?
I think they're
exactly, bullet trains, yeah. What's the population of Japan?
Approximately 126 million.
126 million in Japan, right?
Right.
Okay, so it's a different I guess, so I don't know if that's an issue. I mean, I don't know if that's an issue, right? I don't know. But as far as we are concerned, we're not here to, discuss those kind of, problems that, like you say, beyond your payroll, beyond your pay grade. But one day this might be your job, right? To be a part of, of moving a technology forward. And then you might be a part of a conversation like, wait a minute, what's going on? For example, you guys did some work on Starlink, right? So, Pratik, tell me something you found out about Starlink. One of your bullet points.
The project is to provide broadband internet all over the world, where it's like not possible.
You said Starlink wants to provide internet all over the world?
Yeah, the broadband.
Yep.
All over the
But it's
world.
not possible.
It is. It's probably possible because of the satellite. I mean, they're sending massive amount of satellite in the orbit all around.
All right, so that's what the project is, right? Is to provide for places that, that have no internet. Right? That's Zicheng, what did you find out about Starlink?
Hello?
Yes.
I found out that they use the stateless internet access. They send the stateless to the
satellite. Yeah, satellite.
satellite. Yeah, to the space.
Yep.
Yeah. So yeah, they send the satellite to the space. So that's they want to cover all the Earth, so they can provide internet to everyone.
Yeah.
Yeah, even in the some rural region. Yeah.
That's right. So that's why those kind of things are, extremely helpful, because there are places that you can't reach with cables. Right? There are places you can't reach with cables, and so satellites with the Starlink project is aiming to solve some of that problem. Right? So money has to be spent. People have to be innovative. People have to be able to do things, to solve problems. So problems are solved by people. People see a need and start talking about it and start coming together to say, how can we solve this problem? So things don't just happen automatically. One day it might be your job. You might be in a position to move things forward. Okay, well, let's go on. We spent a lot of time on that topic there. Let's go on and see a few more things here about Ethernet. All right. All right, so another quick read here. If you go to page, let's see. Will, let me go back to you, since you have your book, I think.
Okay.
Let's go back to, where is it? Page, I want to see about this cyclic redundancy check. That's on page 135. 135.
Yep.
Okay, so can you read what it says there?
Where do you want me to start from? Like the second paragraph, or?
That's a good question. Where to start from? So, okay, you know what? Let me just summarize it.
Okay.
So, cyclic redundancy check, CRC. You're going to see this question in your assignment. It's basically a way of checking if there are, if a frame, right? If a frame has been damaged, in transmission. If a frame, or if your data basically has been kind of messed up, it's been damaged while in transit. All right, all to do with the Ethernet. Sometimes, like we said, when you're doing data delivery, right, you have all kinds of issues, bottlenecks, all kinds of interference that might, happen. That might affect the flow of your data, right? The flow of your data. What's that topology again? We talked about the name. What do we call that? What the data flow is called? What's the topology for that?
Logical topology.
Logical, exactly. Logical is how data flows. So when data is flowing, there might be all kinds of conditions that affect that data. Well, the cyclic redundancy check, its job is to, it says right here that when the data has been transmitted, there's a kind of a calculation, right? Some kind of calculation that's taking place on that data before it's transferred, after it arrives. If there's been a problem, it checks, right? It checks, does some kind of math, some kind of a calculation, right? Now, what happens if the data is damaged? What happens if the data is damaged? It says Ethernet, the Ethernet technology just gets rid of the thing, like, just tosses it out. Ethernet technology, if your information is damaged, it's nothing you can do about it. It just throws it away. But there is something else that's available to help. Xenon, you see the very last sentence on that page 135?
Yes.
Can you read that? We want to know what happens when the data is damaged. Who fixes it?
The network protocol, or in some cases, the application sending the data is responsible for resending damaged or missing data, not Ethernet.
Not Ethernet. Something called network protocol. Now, just like the category cables, we haven't discussed network protocols. Network protocols are discussed in chapter 5 and 7. So for some strange reason, we see the word network protocols here, but we haven't even talked about it. Xenon, isn't that weird? That they're talking about things that we haven't discussed?
Yeah.
It's in a different chapter, right? So I think I should write my own book and straighten everything out. Maybe you guys will be my first customers. Anyway, but network protocols are basically services that move, that determine how data moves back and forth. Different services, right? Network services, network protocols, right? So just know that for your assignment, right? If you see that question about what happens to damaged data, what's responsible for resending damaged data? Well, it's something called network protocols, not Ethernet network protocols. So the CRC does the job of checking the data, and then network protocols take care of if things need to be resent. All right, let's go on here. So we'll talk about IEEE. The IEEE, you should know a little bit about it. They are responsible for the guidelines that that determine a lot of networking standards. Okay, so here's another standard here. Remember the standard we just talked about for Ethernet is 802, right? The 802 categories, 802. So we have an 802 here that's attached to Wi-Fi. So just in case you didn't know before, Wi-Fi is short for wireless fidelity, or fidelity, right? Wireless fidelity. So it says right here that so the standard is 802.1, 802.11, right? That is an extension of Ethernet in a wireless way, right? So 802.11 was developed as the wireless wireless extension, if you like, right? The extension. So you don't have wireless if you don't have wires, right? So wireless is not just on its own. For wireless to fully function, right, it can't function at all without some wired connection somewhere. All right, so 802.11 is the specification that determines the whole setup and the whole operation of Wi-Fi, right, determined by the IEEE. And that information is on the later pages in that chapter. If you go over a few more pages to page 148. So the signaling, the channels and stuff like that, all the frequencies, it's all under the discussion of Wi-Fi channels and frequencies and everything, right? So those are things you want to look out for when you're getting ready to do your assignment. Okay, let's see what else, a couple more things here. Sindhu, let me go to you. Are you there?
Yeah.
All right, Sindhu, let's say you walked into a place and they said to you, well, we need we need you to go and get us an AP, an access point, right? We need to make, we need some wireless in that office over there.
Yeah.
When you're going to buy this wireless, when you're going to buy this AP, are you going to ask what shape is the room we're going to put it in? Is that a question that you might ask?
Yeah.
The shape of the room, that you're going to put the thing in.
Yeah.
Why? Why is the shape important?
So you know where like you need the signals to go?
Not where the signals are going to go, right? How the signals are broadcast from that device. So you see right here. So guys, let's look at these two definitions here, right? Access points or the antennas, right? They give out their signals in kind of two ways, right? Omnidirectional and unidirectional. So if you're going to get access points and install them in some office or in some building, you got to know the shape of the space that you're going to install that access point at. Now at home, we just kind of use, we use one access point and it kind of goes up all over the place. But maybe if you're in a more, in a more industrial or commercial building, maybe, and you have like very narrow spaces, for example, or like long hallways, stuff like that. You might need to think about omnidirectional or unidirectional antennas on your access points, because depending on what you get, the signals can move in a certain direction instead of going in a 360 direction. It can go maybe in a kind of like almost like in a horizontal direction, right? So keep an eye on this here. He says here that unidirectional antenna is for placement on one end of a narrow hallway, for example, right? So something for you there, okay? Let's go next. So here are some definitions for you to keep an eye on. Things like absorption, right? That is for radio signals when they get weak traveling on a medium. You have things like diffraction, altering of a wave if it tries to bend around an object, right? So all these issues here affect your signal transmissions. The walls, trees, poles, thick walls, there are all kinds of situations that might affect the flow of Wi-Fi signals, right? It says scattering here, the last one, when a signal changes direction in unpredictable ways, right, causing a loss in signal strength. Unpredictable. Wi-Fi can be unpredictable, all right? Then we have some more information here. Throughput. Eduardo, how does it sound to you here, this definition of throughput?
Let me think about it.
It says the actual amount of data transfer. What does that mean?
I mean, we're talking about quantity of data that is being transferred.
Yep.
It's just saying that it doesn't count errors, but I can't explain. It's too technical for me.
All right, Omar, how does it sound to you? This throughput.
For me,
What do you
like,
think he's saying?
is that like transfer data logs without any like errors or like problems counting?
So I think what he's saying is, we just looked at all the problems we can have with data transfer, right? With Wi-Fi, right? With Wi-Fi. Now, the amount of data that you send may not be the amount of data that you actually receive because of all these issues along the way. So, technical definition is not what was sent, is what was received or what was transferred. The actual one that was transferred is called throughput. So when you hear IT people having conversations, they're always focused on throughput. Like, what's the throughput? How much? What's the real data? The real tangible data that comes through after all. It's like, Omar, do you work?
Actually, not. But I'm doing like part of like freelance.
Okay. Have you worked before and been paid?
Yes.
Okay. Now it's kind of like working and being paid, right? Think about it as when you earn your money, right? When you earn, are you there?
Yes, sir.
Okay, so you get paid. Now, what you get paid, does that all go into your pocket?
Yeah, kind of. In the end of the like end of the month, I get the paid on my pocket. Yeah.
No. Okay, so when you get paid, you don't have to pay any kind of taxes?
No, I have to be due, but in the last of the year.
Yeah, of course. So at the end of the year, right?
Yeah.
But not all the money that you make doesn't all go to you.
Oh yeah, I got you.
You have to take some out, and you got to pay the government, you got to pay the state.
Yeah. I have a bill, something like transport.
Yeah. So at the end of the day, so maybe something like that, right? The data that comes out, or that you send, might be affected by some things along the way, so that it doesn't all get there eventually. There might be a loss, right? There might be a loss, and that's what we mean by throughput here. Okay. Let's look at some more things about Wi-Fi. So Wi-Fi security, right? The security of Wi-Fi is obviously a big deal. There are two technologies that are used with current day wireless devices: WPA and WPA2. WPA stands for wired protected access, and then you have WPA2, which is a more advanced type. So any device that you're going to buy or that is installed for your Wi-Fi absolutely should have this technologies attached to them, WPA, right? And then you can create a password and stuff like that to secure that device. All right. So it's not something that you have to do yourself. It's part of the technology right now. WEP was an older technology, which is no longer relevant to us. All right. So that kind of brings us to the end of chapter 3. And some of the things we talked about here, categories of cables, network protocols, we're going to deal with those guys in more detail in later chapters. In chapter 4, we're going to look a lot at, actual media now, like the cables, right? Copper cables, fiber optic cables. We're going to see some more detail about those guys in chapter 4. And then that's where you guys are going to produce your cables. All right. All right. Let's do the attendance. And then let me see if you guys have questions. And I want to get a sense of your Starlink. So let's go to Dev. Dev, tell us what you find about Starlink while I pull up the attendance.
I checked about the Starlink. I found about like